The throttle shaft is located between the governor and the fuel pump discharge. It allows the operator to reduce the rail pressure and therefore the power to the level needed. The total travel of the throttle shaft is limited by two stop screws located in the throttle shaft housing. Located within the throttle shaft is the fuel adjusting screw, which determines the maximum flow area of the throttle shaft passage when it is wide open. It is used to adjust the rail pressure during calibration. While the throttle shaft is in the closed position, there is always a small amount of fuel flowing through the throttle shaft. This is defined as throttle leakage and is required to keep the fuel lines filled with fuel to cool and lubricate the injectors when the throttle is closed. Throttle leakage is an important setting on the fuel pump. If set too high, it can result in slow deceleration and excessive carboning of the injectors. If set too low, it causes a hesitation in engine response when the throttle is reopened after a downhill run and leads to injector plunger damage. In the lower speed range, the small amount of fuel flowing to the injectors is insufficient to maintain engine idle speed. The necessary additional fuel flows from the governor through the idle passage around the throttle shaft. The amount of fuel needed for idling is a total of the fuel flowing through the idle passage plus some throttle leakage flowing through the throttle shaft. With a given throttle leakage setting, closed throttle idle speed is maintained by controlling rail pressure. This pressure is determined by the position of the governor plunger cut-off shoulder over the idle passage. The forces positioning the governor plunger include the flyweight force and the weight assist spring force, which are balanced by the idle spring force. The combined force of flyweight and weight assist spring acts in the direction to close the idle passage, while the idle spring acts in the direction to open the idle passage. The closed throttle fuel pressure curve is very similar to the open throttle fuel pressure curve. The no-load idle speed on the closed throttle fuel pressure curve corresponds to the high idle or maximum no-load speed on the open throttle fuel pressure curve. Decreasing engine speed will increase the rail pressure. This increase in rail pressure, along with the increase in metering time, maintains a satisfactory idle speed. The change in speed between the no-load idle speed and the speed at which the maximum closed throttle fuel pressure occurs is referred to as the idle droop curve.